Hello, and welcome to the OPLX podcast, bringing you candid and open discussions about all things in the power electronics world.
This show is a part of the Open Power Electronics Network. Visit us online at opelex.net. That's opelex.net for show notes, articles, tutorials, and a whole lot more.
My name is Abhijit Kshirsagar. Currently, I am a professor at the Indian Institute of Technology, Dharwad, where I teach and conduct research in the Electrical Engineering Department.
And I am Lalit Patnaik. Currently, I am a fellow at CERN, Geneva, where I work in the Beans department designing power supplies.
Lalit and I were colleagues at the Indian Institute of Science, Bangalore, where we both completed our MTech and PhD degrees in the Power Electronics Group at the Department of Electronic Systems Engineering, DESE.
Over the coming weeks, we will be talking to leading academics, industry professionals, entrepreneurs, and other leaders in power electronics and allied fields. We hope you will find this useful and entertaining. So sit back and enjoy. Hello everyone, welcome to our podcast. This episode we are interviewing Professor Sheldon Williamson, and he is currently a professor at the Ontario Tech University. He's the director of the Smart Transportation, Electrification and Energy Research Group, that's called the STEER Group. And I had the good fortune of working with Sheldon for a couple of years. I was doing my postdoc under his supervision, so we are very happy to have him on our show. And I would love Sheldon to maybe elaborate on this introduction. Tell us more.
So thanks Lalit for the kind introduction. Yes, I mean, I've been at Ontario Tech for the last 5 years. It's coming up to be 5 years now, since 2014. In fact, 6 years, little over 5 years. And before that, I was at Concordia University for 8 years. So yeah, in all, this June, I will have 14 years of academic experience under my belt. And before that, obviously, as you know, I completed my PhD in Chicago and master's as well at the Illinois Institute of Technology in Chicago. So yeah, I mean, the university is growing. It's been, last 17 years or so for this university, Ontario Tech, which is very new by the standards of Ontario and Canada. So we are one of the newest universities. So it's been a fun ride so far, and I'm glad to be on the show, actually. Thank you for having me.
Great. So our next question would be to just clear the ice or thaw the ice a bit. Could you walk us through your average day at the university? How does it look like?
Right. So it really depends on the... thanks for the question. That's a great question, by the way, because on an average, it depends on the teaching day or not, whether I have a class or not. So on a day when I don't have class, that is research intensive, typically I would come in, meet the students, graduate students, typically give them times. I would have already had a pile of emails, that would have piled up over a day or two, asking for requests to meet. So I would schedule those meetings first, meet the grad students, and then typically during the middle of the day or towards the end of the day, industry partners tend to have meetings, either like this, like what we are doing, like an online call or a meeting or even a phone call. So those are scheduled for the middle part of the day. Then again, before the end of the day, I meet the grad students, visit the lab. As you know, you spent with us over a year as a postdoc. So, sometimes there are ad hoc meetings that happen or are called for by either the postdocs or the PhD students. So I would go meet them and try and solve those issues. Other than that, there are also, don't forget, faculty members have to also, meet for admin purposes, like service towards the department, service towards faculty or service towards even university, like president's meeting, so on and so forth. So those are all packed in a typical day. Now that would be on a non-teaching day. On a teaching day, obviously we keep our window free for teaching and also office hours. I typically like to have office hours right after my class, where the students are fresh with their thoughts and also from the previous week's class, so they can come and ask questions. So that would be on a teaching day, other than all the other things that I mentioned on a non-teaching day. So that's my typical day. Other than that, sometimes I keep 1 or 2 days in a week. There is something called proposal season, and you are very aware of that also. Like in North America, or specifically in Canada, but North America in general, summertime as well as fall is dedicated to proposal writing, because most of the deadlines for federal and provincial government proposals, call for proposals or projects, lie in the September-October time frame. And so we have to dedicate almost the end of summer towards into fall. Some of us, like who are last minute, will keep most of their fall semester busy with proposal writing. So it really depends how you plan the day. For me, it starts from end of summer. So end of summer is basically in North America, as you know, June, July, August, right? And so into September.
Yeah.
And then, so that would be a typical day for a faculty member, and the same goes for me.
Thanks, Sheldon. That's a very nice point that you made, that you want to have office hours right after the lecture. Can you tell us a little bit about what you're teaching and what sort of courses you're handling this semester or last few semesters?
Right.
And also touch on, are there specific courses that you want to teach in the near future?
Right. So so like I said, there are two things. First, when I started my career, I was more assigned courses by the department. It was not like what I want to teach. But what happened after 1 year is that the new wave. So typically I teach power electronics, fundamentals of motor drives, advanced motor drives, advanced power electronics, so on and so forth. Also fundamentals of electric machines. So these were some of the things that we basically that I covered. The thing that I wanted to teach was electric vehicles right from the beginning, but that actually didn't happen, as I said, because of the being an assistant professor tenure track. They mostly gave me these fundamental courses to teach. But in the second year itself, I saw interest from the students. I included a special topics course, such as electric transportation, and then it had a massive response, and then it became a permanent course in the syllabus. And so that was something I did at Concordia University when I just joined. Then when I came to Ontario Tech after 8 years there at Concordia, what happened was basically right from the get-go, I joined as a Canada Research Chair. So there it was a different initiative, right? The whole idea was to have research-intensive activities, etc. So I organized a couple of courses, one on electric transportation, graduate course, and one on electric energy storage systems, which is also a graduate course. So I teach two of those courses. Other than that, I do teach alternatively power electronics and motor drives. So those are the courses that I teach. Or moving forward, as you asked me, what I would like to do, like in terms of teaching, I have done quite a bit now. I want to start a program in transportation electrification, and that is where I see the universities moving towards. Electric transportation, autonomous e-mobility programs. So like having, what courses would you like to see in that program? That would have to be designed like a syllabus, right? And so a specialized program for students to opt for when they are taking admission right from the get-go. So that is my next step, and that is the mandate actually the university and I are still talking about right now, and that might be the next step moving forward.
Yeah, that's very interesting.
Just a follow-up question on that.
Yeah.
How much do you think traditional courses like, power electronics, drives, machines.
Yeah.
What percentage of that do you think are going to make it as they are into these new programs, and how much do you think is going to be sort of changed?
Oh, definitely.
Can you give us a ballpark on that?
Yeah, definitely. I would love to actually. In fact, that forms the crux of our courses, because I've started to design the program already as we speak. Since the last 4-5 months, I've been writing down the courses and talking to the different instructors. What has happened is I see there are lots of power electronics, advanced power electronics. We have 3 power electronics courses now in at the Ontario Tech University, and also we have 3 motor drives courses that are included. Apart from that, in fact, I would like to point out also few advanced courses such as PCB design, so on and so forth, that even Lalit, and even in the past one of your own colleagues, Dr. Najjad Abdul Aziz, also introduced in the syllabus. So we've included those, and also control and linear systems, and then some non-linear control courses also. So that in fact forms quite a bit of coursework for a program. So they form really heart and soul of the program, actually, the core course, the fundamental courses. So yeah, it's a good point. And in fact, machine design is one of the courses as well, because you see in North America, machine design is not very popular as a teaching course. Researchers do research, there are several researchers, but like in India, like we all did our undergrad in India, I can speak from experience from India, because we were taught machine design. In fact, there was an elective and a fundamental course. So we started machine design as a fundamental course, as well as an advanced course if you choose to take it as an elective. So I did in my undergrad, and so we had 2 design courses, but in North America there isn't any one even. So one of the machine design courses, fundamental, I have also included in the program.
Yeah, actually, that very nicely leads us to something that we wanted to ask you about because you're talking about undergrad education of the students right now. But what would be very interesting for us to know is what are the kinds of things that you were exposed to in your own undergraduate education that sort of shaped your career path and your interest into this domain of power electronics?
Right. So, like I said, I did my undergrad at Father Agnell's college, which is Father CRIT, Conseco Rodriguez Institute of Technology, in New Bombay, in which is an outskirts, as you know, if those of you are familiar with Mumbai, is basically Navi Mumbai, right? So that is affiliated with the University of Mumbai, and there were a plethora of courses right from the beginning in terms of in terms of power courses. So we did a lot of power systems courses, we did a lot of control systems courses, as is typical in an electrical engineering program in an undergrad system in India. Towards third year of my engineering, that's when I started to take a penchant for power electronics. I started to get attracted towards power electronics because we started a lot of machines courses, and we had machines 1, 2 and 3, which covered quite a bit and went a little bit into drives as well. So we started to get attracted towards fascinated towards how just simple circuits can do wonders in terms of converting power or energy. So that the topologies, the different switching schemes, so on and so forth, and then how to design a feedback loop and a controller for that kind of merged in well. As an undergrad, I started to appreciate power electronics, circuits and control systems as core courses for moving forward. So that's where and that's where it led me to my research interests as well in this field. So yeah, it started all at I think around the third year, which is the 5th semester. So you're in your early late teens and maybe entering 20s, right? And that's when it all started for me as a spark, so to speak. Yeah.
Small question here. At the end of your bachelor's, were you totally focused on getting into power electronics or power as a career, or did you have some doubts and,
Right.
okay, I'm not sure, or how, can you just walk us through what was your frame of mind at that point?
Yeah, that is true. You are very right, because many of my colleagues, in fact, were in that frame of mind. For me, I had started, towards my 7th and 8th semester, I started looking for graduate studies. And that time I was already emailing quite a bit of power electronics world-renowned professors, such as Professor Fang Peng from Michigan State University, Professor Ali Emadi at IIT Chicago, so on and so forth. So, in fact, I got admitted into Michigan State as well as IIT Chicago way before I even graduated from undergrad. So they liked my... and in fact, I had a lot of email communication with several other professors. So I really had my mind set on it. It's... like I had to do power electronics moving forward, and I wanted to do a master's. I know it was difficult, so many of them actually wanted me to commit for PhD as well. So I said, no, I definitely want to do my master's plus PhD integrated program, which is typically not done. It's done at some extent, but not quite so often. As you know, in the US, most of you have North American experience, so with undergrads coming from India, people are a little skeptical about the hardware experience, etc. But for me, in fact, I started doing a lot of projects, in fact, at home in this field, in power electronics itself. Like, tinkering with small little things, single phase induction motor, doing an AC chopper for it's a very simple, like triacs, light dimming, all these kind of small little things. So those things I, in fact, articulated very well in my CV at the time I was finishing my undergrad. How to articulate a CV so that North American professors are convinced that you can do stuff and you have a zeal to do it. Like, they don't have time to interview you or call you or, sometimes they'll even delete the email without even giving it a second look. So I had to do that all my final year of my undergrad, and I was quite clear that power electronics was my future.
Moving forward into the future, now that you're completely inside power electronics, would you tell us a few words about your current research and your research group, some details?
Right. So thanks for the question, Lalit. Current research, see, it has evolved over the evolution of the research, in fact, started from, like I said, once I finished my PhD in 2006, I moved to Montreal. From Chicago, I moved to Montreal after finishing my PhD with Professor Ali Emadi in transportation electrification. Those times, 2006, hybrid electric vehicles and related research was going on. Not so much all electric, mind you. So all electric was something in a distant future kind of thing, but hybrids were catching on, efficiency, powertrain, those kind of things, and I had started in that field, mostly focusing on motor drives, drivetrain efficiency improvements through controllers, etc. So it was interesting. First 5-6 years my discovery grant was also on that. So it's like when you join as a fresh assistant prof, you have to write a discovery grant, and so that was my 5-year grant, and they give you to build a program on that. Then I started focusing on charging. Electric vehicles started becoming more and more popular. Plug-in vehicles, hybrid vehicles started to become plug-in electric vehicles, hybrid electric, sorry. So plug-in hybrid vehicles needed to charge at some point. But charging from solar power fascinated me, because that would be more green and freely available renewable energy. So we started to work on power converters, interface between PV and grid and EVs. And then more recently, the push towards even getting away from plugged charging started. So wireless charging took over, and moving forward, autonomous vehicles will come and they will be electrified in some form. So wireless charging will be the future, and so that started to take shape in the last 6, 7, 8 years. As you know, Lalit, in the lab, a plethora of PhD students had already graduated and are ongoing as well, and they are about to graduate as well. So specifically mentioning names, Deepa Vincent, Mrs. Deepa Vincent, and then there is Mr. Sang, Yun Sang, as well as in the past, Deepak Rosario, Kunwar Aditya. So we started to build a name for ourselves in this field and niche in that field as well. So apart from grants, writing for federal government, provincial government, which is great, we started to get a lot of interest from industry. Like in power electronics and drives and electric machines, I found one thing in this last 14 years as an academic. Lot of our research interests are also kind of tied in with what the industry wants, because unless and until there is an actual product at the end of the tunnel, at the end of the line, really the research means nothing. We are not scientists, we are engineers. That's what I always tell my grad students. You might have heard me saying that few times in our group meetings as well. It's think of a product, how do you develop? So research is one thing and development is another, right? So so industry driven projects also are in line with this. Then the other thing about electric vehicles started is in the last decade or so is the battery not lasting long for charge, constant charge, recharge, fast charging, so on and so forth. And you were heavily involved in battery management systems as well while you spent time at our lab, is lengthening the lifetime of the battery pack itself or the cells that constitute the pack. And so that is one more thing that we are focusing on. And apart from that is also high power traction motor drives. I've never lost focus of my research on drives, and also with industry we have good relationships building motor drives, like in the past for TM4, Opel RT themselves, we work with them building drives modules for them. And then now more recently working with companies such as Inmotive, Linamar Corporation. So it's really, and DNV Electronics more recently as well. So last 14 years has been, I would say, power packed with industry projects, no pun intended, but industry driven, as well as some of the core research ideas that I had, moving forward, like renewable energy charging, so on and so forth. So it's the best part about it, and the most fruitful part, Lalit, is you see them actually being used, in industry. You see the fruits of your research being used. And that's the most impactful thing, right? The impact that your research makes. And that gives a lot of pleasure, actually, when you see that happen. So really, and it's only the beginning. For me, I speak of 14 years as a long time. There are professors in power electronics who have been in the business for 25, 30 plus years, and they are still passionate and still learning. So, for us, it is only the beginning.
That's great to hear. Quick sort of comment and question on the wireless charging there. Do you think wireless is seeing uptake, especially in EVs or, higher power, not like wireless mobile chargers and all, slightly higher power? Do you think wireless is on track to good adoption, or do you think it's lacking? And if it's lacking, then what do you think is the barrier there?
Yeah, I think there are a couple things here. Good question actually. It is, we would love to see it implemented on a mass scale already, because it's about time. Look around us, like we are in this COVID-19 situation. Not to bring it up during this, this podcast, but it is the truth. Mobility will change. The way we drive, now even electric vehicles, even plugging in, going to the concept of charging station was going to be was being proposed, but charging stations with plugged chargers still needs human interface. I think that is going to go. The way we are going to work or operate in terms of transportation is going to completely change after this situation. At least in the short term, 2 to 3, 4 years, people are going to be scared to be coming near to other people. Okay, so honestly speaking, wireless charging will be adopted. Now, how fast depends on standards. One thing is the standards are not yet mature. Okay. Secondly, power levels, as you mentioned, is also something that has to be looked at. So those are things that are impeding its acceptance. Social acceptance is another thing. Like, will we be affected by the radiations? So on and so forth. So whatever the problems are actually driving research right now in our lab. and several labs who are actually worldwide doing this work. So that's where we are at with the wireless charging. Yeah,
That's really nice. Thanks. So, just to follow up again on that, do you think students who join your research group and who, are aspiring electrical engineers in power electronics and related fields, do you think they have the right skill set to attack all of these problems that you've been describing to us in the last few minutes? Or do you think that there's something lacking? Do you think that they are good enough, but they need little more, let's just say, a little more tweaking? What would you say as a professor?
Yeah, I would say as a professor, what I've seen actually is when students come in and they want to do work on wireless charging specifically, is if you're specifically targeting wireless power transfer, I would say 60-40. So 60% of the time they are equipped. 60% of their skill sets are good enough. But the 40% has to come from actual trial and error and failure. So when they fail, they learn. And that's when usually that happens in the first year of their PhD research. Is several failures, especially during simulations, what they think would work but would not. It's mostly to do with circuits, resonant tank circuits, modeling, so on and so forth, right? And then when they get that exactly right in simulations and modeling, then they are ready to tackle the experimental setup, which is typically in their second and third years of their PhD, and then go on to do rigorous testing. So I think, and of course it also depends on whether it is an industry project or not, right? I mean, there are some industry specifications. So designing according to specs is also something that they learn, and they master that art during the second and third year. And that's where that training needs to be imparted on behalf of postdoc fellows as well as professors who are supervising these graduate students, PhD students.
Since we are talking of kind of a skill gap or knowledge gap in the students that needs to be covered, what in your opinion are the changes that we require in the current syllabus, because this syllabus sort of has not kept up to date with the requirements? So what kind of changes do you see in that framework?
Yeah, many universities, I can speak for North America, have already started changing, but also I can even proudly say that I have been last 2-3 years been looking at syllabi of several universities within India also. Mm-hmm. Right, as a consultant, as a well-wisher, many universities have reached out to me from India as well. And what I see is really stuck-up courses, pardon my language, is quote-unquote stuck up, because I say they are stuck in first gear, they are teaching the same old courses, and students are having to go to, things like Coursera or even the courses from IISc, right? To learn advanced power electronics courses or drives courses. So that is quite unfortunate. What we are doing now is actually taking this. North American universities are doing it, and so are Indian universities with whom I have been dealing with, is reforming their programs, especially to move towards a smart grid or transportation electrification, including advanced power electronics courses as electives for undergrads. Don't be scared. The problem is that universities are very scared to revamp the syllabus, right? Mm-hmm. And that's where, and then the other part is also the teaching force. Like, how can teachers teach these courses, mm-hmm. right? So what I have been doing is also teach teachers how to teach these courses. Does that make sense? Mm-hmm. Right? Mm-hmm. So you need to invest in little bit of, so specifically for India, you need to invest a little bit in foreign faculty or postdocs who have graduated from abroad or done PhDs and postdocs abroad, coming in back to India to teach. Mm-hmm. That may be something mm-hmm. that will benefit universities in India. And abroad, I have seen already programs being included, like our university itself, and several other universities have already started to implement, like smart grid option, mm-hmm. transportation electrification option, mm-hmm. and then converting the option into a program, as I mm-hmm. earlier mentioned. Mm-hmm. So Yeah.
Okay, so we are running out of time here. So just a few quick questions before we sort of wrap this up. We've had a great conversation so far.
Sure.
Just to ask you, what are the big picture problems for the future that you envision? And, BTech students who are in electrical are not going to be focusing on just power and, let's say, so they're going to be learning a wide variety of courses and topics and things like that. So what do you think are the big topics that are sort of relevant to the big problems of the future, let's say 25, 30 years down the line, that you think students should be thinking about now so that they are well equipped to address those problems and solve those problems in the future?
Sure. One of the biggest things is also right now futuristic topics would be, one is the wireless charging. From there stems autonomous vehicles, and from autonomous vehicles, not just vehicles but mobility. I mean, transforming the whole transportation industry. It could be air vehicles, land vehicles, sea vehicles, making them completely autonomous, vehicles charging each other or communicating with each other. These need skill sets, not just power electronics and drives and control, but also from communications field, software field, mechanical engineering field, aerodynamics, so on and so forth. So working with a team of engineers and speaking their language for us as power electronics engineers will be of prime importance moving forward. Secondly is, because of all this autonomous behaviors which is not having human interface, will be the issue of security. So cyber security in power electronics, cyber security in drives. You will already see there are certain, like power electronics transactions, industrial electronics transactions, having papers, and even power electronics research programs in universities are looking at cyber security in power electronics. And so these may be the short term to long term challenges depending on how long it takes to mature. So I would say at least the next 10-15 years we can focus on these technologies, and I think that's a lot of work to do. I mean, students have to really and programs have to prep the students accordingly, and students have to be willing to be learning these technologies rapidly.
Thank you. That's a very nice answer.
Sure.
Yes, Lalit.
Basically, in all these domains that you mentioned, and especially in terms of the power electronic side of these projects or different ventures, you have a lot of work going on in the IEEE Power Electronics Society, what is called as PELS.
Yes.
So would you tell us a few words about your efforts there as a team, and what are the new things happening there?
So in PELS, we are part of many committees. In fact, I'm part of several technical committees within the Power Electronics Society, and that is where that drives most of the research and standards. I'm also on the standards committee for PELS as well as the Industrial Electronics Society. So that gives me a lot of knowledge and ideas when I sit in these committees, sit in and listen to world-renowned experts from academia, industry as well, right, who participate heavily in these committees and societies. Secondly, we've also now recently started PELS initiative on digital media and education, which I'm also part of that committee, which is headed by Professor Prasad Njeti, who is a TI professor in power electronics at Texas A&M University, as you know. So he and I, as well as several others who are on this committee, I think there are about 10 or 12 members worldwide, spread geographically. We are looking to improve the education system in power electronics, or the business of educating educators, as I said, as to how to teach futuristic courses, how to go, and then also we do, as you are doing now through OpenX, this podcast, basically, podcasts through the PELS Digital Media Committee, trying to educate the common public about upcoming topics, futuristic topics, interviewing world-renowned experts in that field. So really, from a podcast standpoint, that's where I gain my experience. It's been a new initiative in PELS, the Digital Media and Education Committee. So yeah, this is basically what's going on within PELS. We also have the new open source journal now within PELS, as you may have known or noticed in last 6 months or so. I mean, it's been its first issue will come out this year, in fact.
Yeah.
So papers are being accepted there, and that will be open source. So I mean, again, papers will be coming and they will be reviewed like any other paper, right, with the same stringent standards that Power Electronics Society maintains. So just like the transactions on power electronics, so the value will be no less, and the quality will be of utmost importance. So those are things which are initiatives within PELS that are forthcoming.
Thank you. So just as we wrap up, how do our listeners find you online? Do you have a social media profile? Can you tell us about your profile page on your university?
Yes.
Web page? How do they find you?
So we are, as Lalit mentioned at the beginning of the chat, we are known as the Smart Transportation, Electrification and Energy Research Group, STEER for short, STEER. So at STEER Group is our handle on Twitter, and also you can find us on LinkedIn, and you can find us online as well. So if you just do a quick search on Google for STEER Group, you can find us online, and our updates are and achievements or breakthroughs or research projects, students' emails and contacts, so on and so forth, including my contact and how to reach me is all there. So you can reach us through social media very easily, and we are readily available to even respond. Most of the times we just respond ASAP. So it's like having a chat dynamically. So, and we really love to help anybody who reaches out. We never hesitate to help.
We will, I think, add all these links that you talked about in the show notes so that people can access it in text as well.
Sure. Absolutely.
Thank you so much, Sheldon, for giving us your valuable time and all your experience.
Oh, you're welcome.
It was an excellent conversation. Most
welcome. I really enjoyed chatting with you guys. I wish the podcast turns out great, and I wish you all the very best as a group, the OpelX group. It's a great initiative. I look forward to helping you guys online as well as offline.
Thank you, Sheldon. Thanks very much.
Thanks, Abhijit. Take care. Bye-bye.
Bye.
Have a great day.